Now, just reviewing our mass-to-mass problems, we know that we need a balanced equation. So the first two deal with balancing the equation. Okay, we need to determine what is known and what is not unknown. That's all review. We have to do this. Okay, it says mass to mass, but what we're going to do today is we're going to do mass to volume, volume to mass, volume to volume. And it's a lot easier than what you've been doing previously. So, we have to do these with all types of problem. We need a balanced equation. We need to know what we have and what we are looking for. Now, the steps that are changing are 4 through 7. Because if we have a volume, if we need to find volume, do we need to determine the molar masses? We need a volume. Do we need the molar mass to do so? If we need a volume, what do we need to have? Gases, STP. Okay? So here, on the step that it says convert mass of the known substance to moles, that's a flux capacitor step I told you. We can use anything on the flux capacitor. So it could say convert volume of the known substance to moles. It could say convert atoms of the known substance to moles. This step's going to be the same because the molar ratio comes from the balance equation, whether we're dealing with volume, whether we're dealing with mass, whether we're dealing with representative particles. And then the seventh step, too, can also change. This can also change. Convert moles of the unknown substance to mass. Once again, we can convert that to volume. Now, the reason I said that this is easier, because we don't have to calculate the molar mass. We know it's a constant for the other ones. Avogadro's number, constant. Okay? Molar volume, constant if we have STP in the gases. All right? So, give you a second here to copy down the first. All right, the question states, what volume of chlorine gas at STP will react with antimony to form 58.9 grams of antimony trichloride? Very first thing I need to do is get a balanced chemical equation. So, I know that I'm looking for antimony on my periodic table. SB is antimony. Drew a blank, I couldn't remember what it was. Antimony will react with chlorine gas. Chlorine is a super 7, so it's diatomic. And we're going to get antimony trichloride. I need to balance that. Take my chlorines to 6. Now I have a balanced chemical equation. My next step is to determine the known and unknown. Well, my known is 58.9 grams of antimony trichloride. My volume of chlorine gas is my unknown, so that is what I am trying to convert to. Now, what do I need? What do I need to convert my first step? I need what? The molar mass of antimony trichloride. Go ahead and calculate that. All right, my first step is to convert my grams to moles. So you just calculated the molar mass. I have 58.9 grams of antimony trichloride. And I need to convert that to moles. What was my molar mass of antimony trichloride? Mercedes, what'd you get? I don't think you did it right either. Okay, Kyle, what'd you get molar mass, antimony trichloride? Did you guys even do it? Okay. What was it? 228.119. Grams of antimony trichloride. That's 1 mole. Antimony trichloride. Now I get a cancellation. I need to go then to my molar ratio. I want moles of antimony trichloride to cancel, so I go 2 mole SbCl3. And I'm trying to find chlorine gas, so I have 3 mole of chlorine gas. Now my last step here is I'm going from moles of chlorine gas. Cancel there. I have it in moles of chlorine gas, and I need to go to volume of chlorine gas. Well, I know that at STP, 1 mole of chlorine gas is 22.4 liters of chlorine gas. My moles of chlorine gas will cancel. So, I take 58.9 and I do the math. And with 3 significant figures, I come up with 8.68 liters of chlorine gas. So this would be classified as a mass to volume problem. I've taken the mass of one substance and converted it to the volume of another substance. I'll give you time to copy down the question. Okay, the question states ammonia reacts with oxygen at STP to form nitrogen monoxide and water. If 87 or 85.7 liters of ammonia react, how many grams of each product will form? First thing I'm going to do is I'm going to get a balanced chemical equation. Ammonia is NH3, reacts with oxygen, diatomic. to give nitrogen monoxide and water. Now, as I look at that, I can see that I'm going to have a little bit of problem here with my ammonia, because I have a 3 here with hydrogen, and I have a 2 there. Okay? Well, I've already got this balanced, so I'm just going to do it. To save us a little time. So if I look at that, just double checking, 4 N's, 4 N's, 12 hydrogens, 10 oxygens, 6 and 4 is 10 oxygens, balanced equation. Can I reduce it? No, I cannot. So that is my balanced equation. Now, although it tells you to find out how many grams of each product, I'm only going to go to nitrogen monoxide. So what I'm going to do is I'm going to take what I know, 85 liters of ammonia, and I'm going to convert that to grams, and it's going to be grams of nitrogen monoxide. So, 85.7 liters of ammonia. I need to take that to moles. The flux capacitor one, I have liters of ammonia. I know that 22.4 liters of ammonia is 1 mole of ammonia. My liters of ammonia cancel. I've now converted that into moles of ammonia. Now I need to use my molar ratio to go from my known to my unknown. So, 4 moles of ammonia. I said I was going to nitrogen monoxide. So I get a 4 over a 4, 4 moles of NO, 4 moles of NH3. Now my next step is that I have to find the molar mass of ammonia. So, actually that's incorrect. The molar mass of nitrogen monoxide. Nitrogen is 14.0067. Oxygen's 15.9994. And I come up with a value of 30.0061 grams of NO. That is 1 mole of NO. 1 mole of NO, 1 mole of NO cancels. So, my final answer is going to be in grams of NO based on my label. Get that cancel in there. So, when I do my math, I come up with 3 significant digits. (115 grams of nitrogen monoxide. Got a thumbs up? Emily, you not playing today? Okay. Ethan, you're out? Okay. So now this one was a volume to mass. The only one we haven't done yet is a volume to volume. Okay. And this is the easiest of them all to me. I'll give you a second to copy the question. The question states, how many liters of hydrogen and of nitrogen are used to produce 200 liters of ammonia at STP? Balanced chemical equation need to start with. So, we are taking hydrogen, combining it with nitrogen to give us ammonia. So I'm going to need to balance that. That balances my nitrogens. That balances my hydrogens, correct? Now, once again, it says to do both of these. I'm only going to convert to one of these because they're going to be identical. Okay, well, it won't be identical. It'll be similar doing the other one. So what I'm going to do is I'm going to take 200 liters of ammonia. How many sig figs? There's 3 because of that decimal right there. 200 liters of ammonia, right? I need to convert that to moles. I know that 22.4 liters of ammonia is 1 mole of ammonia. Then I get my molar ratio from my balanced chemical equation. 2 moles of ammonia will need 3 moles of hydrogen. Now finally, I'm trying to find how many liters of hydrogen. I'll make my other conversion box. I know that 1 mole of hydrogen is 22.4 liters hydrogen. I'm going to go back and look. Here I get a cancel. Liters ammonia, moles of ammonia, moles of ammonia, moles of hydrogen, moles of hydrogen. So my final answer is going to be liters of hydrogen gas, which is what I was trying to find. Once I do my math, I come up with I have to put that decimal to signify that I have 3 significant figures. I could put a bar over the last 0. That would signify 3 sig figs. That one's pretty easy. You don't have to do any calculations. Now, I'm going to show you one more problem. And this problem is one similar to something you're going to see on WebAssign today, this weekend, next week, whenever you choose to do your WebAssign. You're going to see a couple of problems like this. So I figured I'd work one for you. So go ahead and copy that down. We'll work it then. Now this problem, ladies and gentlemen, this problem, use the equation provided to answer the questions that follow. The density of oxygen gas is 1.4 to 8 grams per liter. Now, they give you the density of that for some reason. So just store that in the back of your mind. Why did they give me the density? Well, it says, what volume of oxygen can be made from 33 or 3.33 times 10 to the minus second moles of potassium chlorate? Now, think about this. Am I dealing with gases? Am I dealing with gases? Oxygen's a gas. The other two are not, correct? So I cannot use the molar volume because I'm not dealing with gases. We're not at STP. Okay? So, what I need to do, it says what volume? I have to convert a volume. What I'm going to do is I'm going to go from moles of potassium chlorate to a mass of oxygen. Moles to mass of oxygen. I want you to do that right now. Okay? Go from moles to mass of oxygen, and then we'll work the remainder of this problem once we get back from break. Okay? So go from moles to a mass of oxygen. Okay, with this problem, I'm going to start out with this part right here. Now, here's the kind of things that you have to be able to recognize. I'm starting out with moles. So I immediately go to the molar ratio. I don't need to convert anything flux capacitor-wise. I've been given moles. So 3.33 times 10 to the minus 2 mole of KClO3. I flux capacitor that, and I look and I say 2 mole KClO3, 3 mole of oxygen. So now I've converted that into moles of oxygen. I need to go to a mass of an oxygen. Okay, oxygen is 15.9994. So, what's that going to give me? 31.9988. Grams of oxygen, 1 mole of oxygen. That finishes it out. So when I do my math, I come up with 1.5983 grams of oxygen. Now, as I was telling Andrew, the whole reason I did not sig fig this is because I'm not done. So I left that whole value in my calculator right there because I need to use the mass of oxygen to find the volume of oxygen. And in order to do so, I'm going to use the density. I know that D is equal to M over V, so V is equal to M over D as I rework my equation. I just calculated the mass of oxygen, 1.5983 grams. What was the density I was given in the problem? 1.428 grams per liter. So if I take that 1.5983 and I divide it by 1.428, it gives me a value when I put 4 sig figs on it. Actually, I'm only going to put 3 sig figs because right there is only 3. My lower amount of the two. So as I put 3 sig figs on that, I'm going to get 1.12. My label will be liters of oxygen. Questions for me on that one? Now, the big thing to realize here, why can I not use 22.4 liters? We're not at STP, and we don't have gases. If they didn't give me a density, could I do that? Could I do this problem if they didn't give me a density? Absolutely not. Absolutely not. Okay? Now, I reckon that some of you are ready to roll with this. So, the WebAssign that went active this morning, 7.23, is dealing with volume to volume, mass to volume, the likes of that. Now, if I'm going to do this second, I've got another problem that if you want to write this down and work it in about 10 minutes, I'm going to set the timer and I'm going to work it in the back of the room. If you want to work this one, okay? If you feel confident and you're ready to roll, go ahead and go to WebAssign. If you want to watch me work this last example, I'm going to set the timer for 10 minutes, and then I'm going to work it in the back of the room in 10 minutes. Okay? So, have at it.